I've got our first rational inequality on the board here. And this one is nice in the sense that we already have everything on the left side. We're comparing to 0 here on the right. However, on the left side, I can see I've got a quadratic polynomial on the top and a quadratic on the bottom. I want to try to have those factor if they do in fact factor. Now, I'm working just over the real numbers here because we're talking about inequalities, and that means we're working in the real numbers. So in theory, I could have an irreducible quadratic, but let's check. So it's going to be less than or equal to 0. The bottom's the simpler one. That's going to just be x times x minus 2. I can factor out a greatest common factor of x. Now on top, it's a fairly big number as my lead coefficient, but the only numbers that multiply to give me 9 are 1 and 9 and 3 and 3. And I can see I'm going to have ones in this position because those are the only integers that are going to multiply to give me 1. So it looks like 3x plus 1 and 3x plus 1 is going to do it. Let's double check. 9x squared, 3x and 3x, that gives me my 6x plus 1. So if I wanted to, I could rewrite this as 3x plus 1 squared over x times x minus 2 less than or equal to 0. All right, so now let's go ahead and mark off on our number line all of our boundary points. Now, anytime I have a rational expression on the left-hand side like this, I'm going to start with what's in the denominator. The things that would make the denominator 0 are 0, and I'm automatically putting an open circle there. Because I don't care whether this is a strict or an inclusive inequality. If x is 0, this is undefined. Something that's undefined is not less than or equal to 0. It has to be defined to have a definable relationship to 0. So anything that makes the denominator 0 is automatically not included. Okay, so 0 makes the denominator 0, so does 2. So I'm also going to have an open circle at 2. Now I can take a look at what makes the top 0. So if 3x plus 1 is 0, 3x would equal negative 1, x would equal negative 1/3. Okay, so I'll look at negative 1/3. Now, that makes the top 0, so what does it do to the inequality? It makes it true because this is an inclusive inequality. So the fact that it's inclusive says if the fraction is equal to 0, that point gets included. So I'll go ahead and fill in the point there, and now I'm just going to write down what my factors were. So we've got 3x plus 1 squared. That's very important because the fact that we're squaring it actually means I can go ahead and fill out. That's going to be positive on each one of these intervals. The only time it's not positive is when it's 0 at exactly negative 1/3. And then we've got x and x minus 2. And then we'll look at the overall sign. So, to the left of negative 1/3, let's just plug in negative 1. Okay, so x would be negative, negative 1 minus 2 would be negative. A positive and two negatives is going to give me something positive. Now, I've got to check something between 0 and negative 1/3. I can do that. I'm going to try negative 1/6. Okay. If I make the denominator bigger, I make the absolute value of the fraction smaller. Okay. And, of course, that's negative. And if I subtract 2 from it, it's negative. Okay. I can actually see if x is negative at all, these two factors are both going to be negative. So again, that's going to be positive. Okay. And then between 0 and 2, let's try 1. X would be positive. 1 minus 2 would be negative. Two positives and a negative make the left side negative. And then to the right of 2, let's try 3. Okay. So x would be positive, and x minus 2, 3 minus 2, would also be positive. So we get something positive. So now I want to say, well, which intervals did I want? I was looking for where we were less than or equal to 0. If I want to be less than 0, I've already got where we're equal. If I want to be less than 0, that means negative. So I'm going to shade this right here. So this is one of those cases where we have sort of a weird answer because we have just a single point which remember I'm going to just write as the set consisting of that single number, union the interval from 0 to 2. So these will be set braces, these will both be parentheses. Okay.